Previously, we have learned how to solve higher order linear ODEs with constant coefficients. Okay, higher order ODEs with constant coefficients. Previously, we learned this, how to solve them. Whether they are homogeneous or non-homogeneous, we can handle them. But today, we are going to discuss how to solve ODEs with variable coefficients. Okay. With variable coefficients, there's no method, analytical method, which help us to solve ODEs of this form with variable coefficients. In particular, we shall start with the second order. In particular, we shall start with the second order A2 of x y double dash of x plus A1 of x y dash plus A naught of x y equal to some maybe 0 for the timing. So this is basically a homogeneous second order ODE with variable coefficient, means A2 of x, A1 of x, A naught of x. They are variable functions. They are functions of x. They could be any functions of x, but for the timing, we assume that this A2, A1, A naught, for now, we assume that A2 of x, A1 of x, and A naught of x are polynomials. Okay. Of course, these functions could be other than polynomial functions as well, but we'll discuss them later on. But for the time being, we assume that these A2, A1, A naught of x are polynomial functions. For example, if we have an equation of this form, maybe x squared minus 1 y double dash plus x y dash plus 9y equal to 0. So you can see that the A2 of x is x squared minus 1, A1 of x is x, and A naught of x is 9. So these kind of differential equations we are going to handle now, how to solve them. There's no analytical method which can handle this differential equation. We shall discuss the solutions of these kind of differential equations with the help of series methods. Okay. In fact, we are going to discuss two methods. The first one is power series method. And the other one is, it's an advanced form of this method, which is called Frobenius series method, or Frobenius method simply. Let me write it for you somewhere. Okay. The second is Frobenius method or series method, you can say. Okay. So this is basically advanced form of this method. When this method, in fact, we'll discuss it later on, why we use this method. The power series method is an infinite series method. We assume the solution in the form of an infinite series, and then we try to find the solution. Now, in order to discuss power series method, we should know what is a series or infinite series. You guys might have studied Calculus 2 course, in which you have already studied what is sequence and series. There's a question in the chat window. Let me see them. Assalamualaikum. Do we need to on our camera for quiz? Quiz is on Thursday. Yes. Many students have requested me to take quiz on Thursday, so I delayed it till Thursday. Today, we don't have any quiz. So infinite series. What is an infinite series? You guys must have studied already what is a sequence and then what is a series. So let me give you a brief overview on the sequences and series. So if we have a sequence, if we have a sequence, sequence maybe A1 or A0, A1, A2, so on, AN, and so on. Yeah. It can be written in short in this way: AN, where n is from 1 to infinity. It's a sequence. This is how we denote the sequences. Then the infinite series is basically infinite series is the sum of the terms in the sequence. That is, we can say that A0 plus A1 plus A2 plus so on plus AN plus so on. Okay? This is what we have a series. In short, the series can be written as sum, maybe n or I or whatever, n from 0 to infinity, an. This is how we write series in the summation notation. I hope you know what is a summation notation. This is a summation notation. And what does it mean? We take the sum of these terms from by varying n from 0 to infinity. So we put n is equal to 0 first time, we get A0, then plus n is equal to 1, we get A1, then n is equal to 2, we get A2, and so on. This is called the nth term or the general term of the series. Nth term or the general term of this infinite series. Okay. Now, infinite series are basically important. We discussed their convergence and divergence. What is the convergence and divergence of the series? Convergence or divergence of any infinite series. Convergence of an infinite series means informally that the sum of this series is finite. The sum can be computed. The sum is finite. Okay. So convergence means sum of that infinite series is finite. Okay. This is what we mean by convergence. And the divergence means the sum of that given infinite series is infinite. That is basically not finite. So you can read the definition of these things. In my notes, I have written the proper definitions there. So I'm giving you a brief overview on the infinite series so that we can discuss power series method. So how to compute whether the given infinite series is convergent or not? We basically construct a sequence of partial sums. Sequence of partial sums. What is a partial sum? If we are given that series, that is it, this one, this one, in order to discuss the convergence of the series, we compute the sequence of partial sums, a sequence of partial sums. What is it? S1, it has only first term, A1. S2, it contains only first and second. S3, first, second, third, the sum of first three terms, and so on. Sn is equal to A1 plus A2 plus so on plus An. There's a sum of first n terms, and so on. Okay, this is how we construct a sequence of sum of the terms of infinite series. Okay, now this can be in short written as sum k from 1 to n ak, maybe. So if we open up this summation notation, we get this thing. This is a sequence of partial sums, and we prove that if limit n approaches to infinity, Sn is equal to some finite number, okay, is equal to some finite number, which I have written here, L, okay. Then we say that the sequence of partial sums of, if this is finite, then we say that, the given infinite series is convergent. Okay, is convergent. But this involves sequences because Sn is a sequence. Okay, if the limit of that sequence is finite, then we say that the given infinite series is convergent. If that limit is not finite, if L is infinity, then the sum of infinite series would be divergent, means its sum doesn't exist. There is an example of this thing here. For example, if we have a series of this form, summation or sum n from 1 to infinity, 1 over n into n plus 1. It's a series. You just put values of n, 1, 2, 3, so on. We get a series of this form. 1 dot 2, 1 dot here is multiplication, plus 1, 2 dot 3, plus 1 over 3 dot 4, plus so on. So this is basically an infinite series, and we need to know whether this series is convergent or not. Convergent means whether this series has a finite sum or not. What is the method of calculating whether this series is convergent or not? We construct a sequence of partial sums, and then we take the limit of nth partial sum, limit n approaches to infinity. If this limit is finite, then we say that this series is convergent. Okay. Now, by using partial fractions, we can write this thing, or first of all, we have to write the sequence of partial sums of this infinite series. How do we write it? Let me show it to you. Let me go use the other board, maybe. This one. The sequence of partial sums would be S1, it will be 1 over 1 into 2. S2 is 1 over 1 into 2 plus 1 over 2 into 3, and so on. Sn, we need to write Sn, which is 1 over 1 into 2 plus 1 over 2 into 3 plus so on, plus 1 over k into k plus 1. Okay, n into n plus 1, not k. Sorry, you can write it k, because we have already used the n, so it's better to use a different notation. So sk is this, and so on. So this is your kth partial sum or nth partial sum. Now we need to take we need to basically what we do here, we separate these two terms which are in the denominator. They can be written in the form, or we can try its general form. Its general form is sum from k from 1 to maybe 1 to n नहीं होगा. यहाँ पे कोई और notation use कर लें आप. यहाँ पे अगर k है तो it should be k. So you can write here p from 1 to k, 1 over p times p plus 1. So this is your sequence nth partial sum or kth partial sum. Okay. This can be further split into this form p from 1 to k. It is 1 over k plus 1 over plus thing minus p नहीं आएगा, यहाँ पे p आएगा. 1 over p minus 1 over p plus 1. This one. Now, if we take the LCM of these two terms and simplify, we get the similar thing, this one. Okay, now every term here, it can be written in this form: 1 over 1 minus 1 over 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus so on plus 1 over k minus 1 over 1 k plus 1. Now you can see that this term will be cancelled out with this term will be cancelled out with this term, and so on. This term will be cancelled out here somewhere, and we are left with what? This term will be cancelled out with some term somewhere here, and we are left only with 1 over k plus 1. Okay. We'll have only the first term and the last term. So the first term is 1 minus 1 over k plus 1. Okay. So this is our sk, the sequence of partial sums, sk, kth partial sum. Now, if we take the limit on both sides, limit k goes to infinity of 1 over 1 minus 1 over. It is 1 minus 1 over k plus 1. If we take the limit k goes to infinity, 1 over infinity, 0, so we get 1. It is a finite number. It means the given series is convergent, and its sum of that series will be what? 1. Okay, that series which were I considered in this example, it is convergent and it has sum is equal to 1. So this is how we construct a sequence of partial sums, and then we take the limit of the sequence of partial sums, and then we'll find the limit of that sequence. If that sequence, if the limit of that Sn, nth partial sum, is finite, then the series is convergent. Otherwise, it is divergent. So you can see these examples. I have given more examples in my notes. An example of the divergent series as well. You can see these examples. In fact, this is not the topic of this course. It's a topic of Calculus 2 normally. So if you haven't taken the Calculus 2, I would recommend you to revise some of the concepts of sequence and series in the book of Thomas Calculus. I think it's given there. If you find any difficulty reading those concepts, you can discuss with me other than the lecture. Okay, in my office hours, maybe you can obviously ask me for a Zoom meeting to discuss any confusion regarding this concept, regarding this subject. I'll definitely fix a meeting, Zoom meeting with you, and we'll discuss the issues. Now, there are other methods of verifying whether the given series is convergent or not. We'll discuss along with the discussion of power series, of course, how to check whether this method, in fact, series of partial sum method is rarely used. It's basically, you can say, the starting method for checking whether the given series is convergent or not. There are some efficient methods, tests, we'll discuss along with the discussion of power series. Now let us discuss what is a power series and how do we use power series in order to solve the differential equation. Power series. We are still going to discuss only the power series. We're not going to discuss power series method. Okay, we'll discuss power series first, and then the power series method. Now, what is a power series? A power series centered at a point or at a number at a point x is equal to x naught is a series of the form is a series of the form in fact, it is sum from n from 0 to infinity, maybe Cn x minus x naught whole power n. And of course, if we open up this series, what do we obtain? First, wherever we have n in the index or in the power, we put n is equal to 0 first. We get the first term, C naught, anything power 0 is 1. I hope you know it. X minus x naught power 0, which is 1. Then plus, we put n is equal to 1. So we get C1, x minus x naught whole power 1. Plus, we put c is equal to 2. We get C2 and so on. Plus some n is equal to maybe k x minus x naught whole power k plus so on. So this is how we write a power series. Why do we call it power series? Because the x term, the variable term, has powers of basically, you can say positive integers, no negative integer. In fact, it starts from 0, 1, 2, and so on. So with a coefficient, this Cn, these are basically usually the unknown coefficients when we'll discuss power series method. These unknown coefficients, if we can compute these coefficients, then it will become the solution of a differential equation. In fact, we insert this power series as a solution to the differential equation and then try to compute these unknown coefficients. So this is a power series centered at x naught, We will discuss it. Why I have written here centered at x naught. X naught is some point within the domain. Okay, within the domain of that differential equation, or we'll discuss what is x naught and why do we write it here. So if x naught is 0, then the power series becomes then power series can be written as it becomes an summation n from 0 to infinity Cn x power n, which is C naught x power 0 plus C1 x power 1 plus C2 x power 2 plus so on plus some c k x power k plus 1. Okay, this is the kth term, or this is, you can say, the kth term. This is how we write the power series if x naught is 0, means if the power series is centered at origin. I hope you get it. If you have any question, you can ask me.
Sir,
These GG.
doesn't this just make it a polynomial of infinite terms?
Can you repeat your question? I couldn't understand it.
Does it not just become a polynomial of infinite terms if x naught is equals to 0?
It is not a. Yes, it is polynomial. These constants, basically these coefficients C1, C2, C3, they are normally constants. So it's a kind of polynomial, but you can say that it's an infinite degree polynomial, but it is a series. Anything which adds up and doesn't have any end is called a series, infinite series. Now, this is a particular form of the series which has powers, means it's a kind of polynomial of degree infinity. You can say that. Because the variable x appears here as a powers of integral powers, then this is basically, that is why we call it power series. I hope you get it. If you have any confusion, you can discuss with me. Who was?
Thank you.
Examples of the power series could be, or we can write them as, so examples of power series, you can try them. Maybe you can write them as, maybe first one is sum n from 1 to infinity 2 power n minus 1 x power n. Okay, this is an example of the power series. This is a power series. Okay, this is a power series with Cn is what? Cn is 2n minus 1 and xn is xn. Okay, where n is basically what? N is from 1 to up to so on, up to infinity. Now, if we open up this thing, what do we get? We put n is starting from 1. In a series, n could start from 0 or 1. It doesn't matter. Okay. So if we put n is equal to 1, we get 2 power 1 minus 1, 0, which is 1. 1 dot x power 1 plus n is equal to 2. We get 2 power 2 minus 1 is 2. X power 2 plus, when we put n is equal to 3, we get 4 x power 3 plus so on. So this is basically an infinite series, and which is basically a polynomial kind of function. But this polynomial has a degree infinite. Okay. Further example, another example, let me, now this series is a power series centered at x is equal to 0 or x not equal to 0. Because now let us write another series which is centered at some other number other than 0. So n from 0 to infinity x plus 1 whole power n. This is again a power series. Okay, this is again a power series with Cn. Cn is what? It is 1, because we don't have any coefficient here. And how can we write it? We can write it n from 0 to infinity. You can say x minus 1 whole power n. So centered at, what is centered at? Centered at x naught. X naught is what? It is -1. Okay. This is again a power series, and it can be written in this form. When we put n is equal to 0, we get 1 plus x plus 1 plus x plus 1 whole square plus so on. So this is the form of the power series. I hope you get it. Now, what is the convergence of this series? How to discuss the convergence of the series? Using the similar technique, the convergence of this power series is basically, in fact, this power series involves some variable x, x, x. Okay, here we have x plus 1, and so on. But we can only discuss the convergence of an infinite series with constant terms. Okay, not the variable terms, of course. So in order to discuss the convergence of any power series, we need to know at what point you want to discuss the convergence of the series, or at what value of x you need to discuss the convergence of the series. Okay, means for any specific value, does this infinite series converge or not? Okay, for example, I can ask you, or someone in the book, in the questions may ask you, does this series, does this power series maybe converge for x is equal to maybe 1, or x equal to 2, or x equal to 3, or x equal to 0.5, or x equal to 1/2, maybe 1/2, 3/2. So in short, we can discuss the convergence of any series of this kind, or which is a power series, for any particular value of x. We can discuss its convergence or divergence. We cannot discuss its convergence for a general, or for any value of x. Okay, we cannot take x as a general variable. So we have to put some specific value of x, then we can discuss its convergence or divergence. Okay. Similarly, this one, does this series converge for any specific value of x, maybe x is equal to maybe -3/2, or any other value? Okay, so any power series can be convergent or divergent for any specific or particular value of x. We can discuss its convergence or divergence. How to discuss the convergence of this power series? We construct the sequence of partial sums as we have constructed for in the previous example. We construct a sequence of partial sums. We compute Sn. We write Sn or Sk. Then we take a limit on both sides, n approaches to infinity. If that sequence of nth partial sum, if that nth partial sum has a finite limit, then we say that sum of this series is, so this series is convergent, and the sum of that series is the value of that limit, which we obtain after applying the limit on Sn. I hope you get these things. If you have any confusion, you can ask me. Okay. If the limit, as I already told you, the limit of Sn is, if that limit doesn't exist, then we say that the series is divergent. Now, what is the interval of convergence? What is the interval of convergence? It is possible that a series converge for many values of x. It is not necessary that a series can converge only a single value of x. So next thing is interval of convergence of a power series, In fact, it is these concepts are valid for any infinite series as well. But for the timing, we are discussing power series. Every power series has interval of convergence. The interval of convergence is the set of all real numbers x for which the series converge. Okay, set of all values of x belonging to R for which the power series converges is called interval of convergence. Okay, and that interval of convergence could be the subset of R, the set of real number. It could be subset of R. The interval of convergence could be some interval AB. Okay, AB where AB are real numbers. So that interval could be subset of R. In some situation, the set of whole real number R could be the interval of convergence as well. So the next thing is radius of convergence. Radius of convergence of any power series. If you have any confusion, you can ask me any question. You can stop me anywhere. You can. I'll explain further what is the interval of convergence after discussing the radius of convergence with the help of examples. Radius of convergence of a power series, of course. Every power series has a radius of convergence denoted by R. You can say that if R is some number greater than 0, radius is always greater than 0. I hope you know it. Then the power series summation n from 0 to infinity Cn x minus x naught whole power n converges for x minus x naught mod less than R. It's not R, it's R. Oh, sorry. That R. If R is some number, some real number for which the power series converges, then we can say that this is basically the interval of convergence, where R is the radius of convergence, converges for this, and you can say it diverges for x minus x naught mod greater than R. So what is this? It is basically, this is an interval of convergence. Okay, this is how we can define interval of convergence if we have an absolute value here. Of course, using the properties of absolute functions, we can write it in this form. X minus x naught is greater than negative R and less than R. Okay, I hope you know it, how to write it. Now we have to add this thing on the both sides. Then it can be written as x naught, x naught minus R is less than x is less than x naught plus R. Okay, so if So what is this? This is basically interval of convergence, x naught minus r, comma x naught plus r. Okay, this is what? This is always a subset of real numbers, set of real numbers. This is interval of convergence. If any power series converges for every value of this interval, then this interval is called interval of convergence, and r is called the radius of convergence. Okay. And if this is true, then that same series must diverge for all the values outside this interval, other than this interval. Okay. If we draw this interval on the set of on the real line, then we can say that if this is your x naught minus r, and this is your x naught plus r, then we must have x naught here, which is the center of this interval. This is basically open interval. Okay, x naught is the center of this interval, and this length would be r, and this is basically the radius of this interval. Okay, so if any power series converges for all values within this interval, then x naught is the center of this interval and r is the radius of this interval. Okay, that is why we write here x naught, and we call it is the power series centered at x naught. Centered at x naught means there must exist some interval for which this power series is convergent, and that interval must have center as x naught and r as the radius of that interval. Now, within this interval, whatever the value of x you put here in this power series, whatever the value of x, this x as could be any real number within this interval. You can choose any value. And for that value, this power series must converge because this is the interval of convergence. Okay. Now, we have discussed that this power series will converge for this interval and will diverge for this interval. We haven't discussed the endpoints of this interval. Okay. For the endpoints of this interval, endpoints, what are the endpoints? X could be x naught minus r, and the other point is x naught plus r. For these 2 points, which are the endpoints of this subinterval, we need to, by inserting these values term by term in the power series here, first we choose x equal to x naught minus r. Okay, x naught minus r. We check the convergence separately, and then we put x equal to x naught plus r, and then again we check the convergence of the power series by writing the sequence of partial sums or some other methods we'll discuss subsequently after these things. So the convergence at endpoints are not sure. We have to investigate the convergence at endpoints manually or separately, you can say that. Okay, then we can decide whether any side of this interval will be closed or both sides of this interval will be closed. If the series is convergent at both endpoints, then the interval of convergence will be closed interval, which includes the endpoints. Now let us discuss the example of this thing. Before discussing the example, we need to discuss another definition, which is absolute convergence. Absolute convergence. Absolute convergence is what? If any power series converges within the interval of convergence, then its absolute value, or you can say, if this is the power series, which is given n is equal to 0 to infinity, Cn x minus x naught whole power n. If this series converges for all values of x within the interval, which is interval of convergence, x naught minus r and x naught plus r, then the sum of absolute values of this series, then you can say the sum of absolute terms of this series, that is what? Summation n from 0 to infinity absolute of Cn x minus x naught whole power n, absolute values. So sum of absolute values of this series must be convergent also for all values of x within this interval, x naught minus r, x naught plus r. It's a basically theorem. We can prove it, but I'm not going to discuss the proof of the theorem. Then we say that this series is absolutely convergent. Okay, if the sum of absolute values of terms of the series, if this series, the absolute, we take the sum of the absolute values of the terms of this series. If this is convergent, then we say that this series is absolutely convergent. Okay, absolutely convergent means even if we take the absolute values of each term of this series, then it will still be convergent. So that's why we call it absolutely convergent.
Sir, I have a question. So a convergent power series doesn't necessarily imply that it's absolutely convergent, right?
Yes. If this power series is convergent, then it must be absolutely convergent as well.
Okay, so one implies the other always.
Okay. The other one, it is the inverse of this thing is not true. If a series or a power series is absolutely convergent, means if this series is convergent, if this series might not be convergent. Okay.
Okay, yes.
If this is convergent, then this series must be convergent. Okay. If a power series is convergent, then it must be absolutely convergent. Okay. But the reverse of this thing is not true. If a power series is absolutely convergent, then the original series might not be convergent. Okay, you got it?
Yes, sir.
Okay. Now, how to check whether the given series is convergent or not? Let me. Now, why this is important? Why this thing is important that if this series is convergent, then this series must be convergent. यहाँ पे मैंने इसीलिए लिखा है कि अगर ये series converge करती है for all values of x within some interval, then the sum of absolute values of absolute terms of this series, this must be convergent for all values of x within the same intervals. Okay, so this is must be. Okay, this is must be if this is convergent. Okay, this implies that, but the reverse doesn't imply. Okay, now why is this important? This is very important in order to discuss certain other methods to check whether the series is convergent or not. And also it helps us to find the radius of convergence and interval of convergence of the given power series. So if देखिए यहाँ पे दोनों के interval of convergence same होंगे, दोनों का center of convergence same होगा, center of interval of convergence, and then दोनों का radius of convergence same होगा. ठीक है, हम इसका फाइंड नहीं कर सकते, बट इसका फाइंड कर सकते हैं. अगर हम इस सीरीज का इंटरवल ऑफ कन्वर्जेंस फाइंड कर लें, तो जो इंटरवल ऑफ कन्वर्जेंस इसका होगा, इसका भी वही होगा. ठीक है, सो दिस इज why we are discussing these things. Now, in order to check the convergence of this series is possible, but in order to, it is very difficult to check the convergence of this series because it doesn't have absolute values. Okay, it could be alternating series, plus minus हो सकता है उसमें. ठीक है, so discussing the convergence of this series is difficult as compared to this series. So we are going to discuss the convergence of this series by using different methods. If this series is convergent, okay, provided that this is also convergent, then we can easily find the radius of convergence of this series, which will imply the interval of convergence of this series. Okay. Now, there is a ratio test which help us to find the convergence interval of convergence. Ratio test. For example, the similar one, maybe this one. How to find the interval of convergence for this series? If it exists. Now, convergence by ratio test. These tests we discuss normally in the Calculus 2 course, but here I need to review this thing because we'll use this test in order to discuss the convergence of the power series solutions of differential equation. Okay? So the convergence of power series can often be determined by the ratio test defined by. So our power series is normally what it is, n from 0 to infinity, Cn x minus x naught whole power n. Okay. So what is ratio test? Ratio test is that we take the ratio of, we define a ratio of two consecutive terms of this particular series of two consecutive terms, which can be, you can say that हर दो कंसेक्यूटिव टर्म्स को तो नहीं कर सकते क्योंकि दिस इज अ जनरल सीरीज, इट्स जनरल टर्म, तो इसकी जनरल टर्म की दो कंसेक्यूटिव हम देखते हैं, cn+1 times x minus x naught power n plus 1 divided by cn x minus x naught whole power n. ये दो कंसेक्यूटिव टर्म्स हैं, अगर n कोई पर्टिकुलर टर्म है तो उससे नेक्स्ट टर्म क्या होगी, n+1 पावर के साथ. सो दो कंसेक्यूटिव टर्म्स का रेशियो हमने लिया और उसकी एब्सोल्यूट वैल्यू ली और फिर हमने इस पे लिमिट लगा दी n goes to infinity. अगर ये ratio, if the limit of this ratio is finite, finite means it is some number L. Okay, then there are cases. If this number L is less than 1, what would it mean that the next term is less than the previous term? If number 1, if L is less than 1, what does it mean? The ratio of next and previous term is less than 1. It means the subsequent terms of the infinite series are getting smaller and smaller. This is what it means. Then from this expression we can find the interval of convergence. Okay, how? बाकी दूसरे केस में क्या होगा, अगर L greater than 1 है तो ये डाइवर्जेंट होगा. What does it mean? कि ये रेशियो जो है इसका ये this the ratio of these next and previous term is greater than 1. What does it mean? Each subsequent term in the power series is greater than the previous term. Then आप क्योंकि every next term is greater than the previous term, तो आपने infinite many such terms का sum लेना है. तो terms बड़ी होती जा रही हैं तो उनका sum क्या होगा, finite नहीं होगा. अगर next terms क्या हो रही हैं, छोटी हो रही हैं, तो फिर क्या होगा, they will stop somewhere, they are approaching to zero in fact. तो अगर ये zero को approach कर रही है तो definitely उसका sum क्या होगा, exist करेगा. ठीक है, this is how we try to discuss these things. अगर L less than 1 है तो ये जो सीरीज होगी ये absolutely convergent होगी. Yeah, you can say that this series is convergent. ठीक है, if this is L is less than 1, this means given series is absolutely convergent. Okay, अगर L greater than 1 है तो given series क्या होगी, divergent. तीसरे केस में अगर L equal to 1 आ जाता है, there are three possibilities only. एक ये है कि इसकी लिमिट L less than 1 है, एक ये है greater than 1 है, तो तीसरी पॉसिबिलिटी क्या है, L is equal to 1. In this case this test fails. This test is not appropriate here to tell us whether the given series is absolutely convergent or not. Okay, so these are three cases. Then in third case we use some other test to check whether the given series is absolutely convergent or not. Okay, if this limit is less than 1, then we move further in order to find, अगर L greater than 1 आ जाता है तो ये divergent हो जाएगी. अगर divergent है तो we cannot find the interval of convergence, obviously we cannot find the radius of convergence. अगर L equal to 1 आता है तो test fail हो जाता है, we will try some other test. अगर L less than 1 है, then what? Then we can find the interval of convergence as well as radius of convergence. Okay, I hope you get it. If you have any confusion, you can ask me. Okay, now let's try to find the interval and radius of convergence for the power series. Okay. Now, in that case, we have limit n approaches to infinity, cn plus 1, x minus x naught power n plus 1 over Cn x minus x naught whole power n, this mod. Okay. If this is less than 1, means is equal to L and L is less than 1, then we can cancel this thing with n. Okay, here, what we are left with, here we have absolute value. So limit n goes to infinity. We have absolute of Cn plus 1 over Cn mod into absolute of x minus x naught less than 1. Okay, this thing. 1, not 11. Okay. Now, we don't have n here. The limit applies only on this thing, Cn plus 1 over n, over Cn. So this thing can be taken out of the limit, this, and then limit n goes to infinity, Cn plus 1 over Cn mod less than 1. Okay. Now, it depends what is the value of this limit. Okay, what is the value of this limit? So this could be some finite number, because हमने कहा हुआ है कि ये limit जो है वो less than 1 है. Okay. So we say that इसकी value कोई finite number है. You can say maybe इसका answer जो है वो कुछ भी कर लें आप, m कह लें. ठीक है. So this is m. अगर इसकी वैल्यू m आ जाती है तो m को आप उस तरफ डिवाइड कर दें. ठीक है. अगर आप दूसरी तरफ डिवाइड करेंगे तो what do we get here? We get x minus x naught mod less than 1 over m. 1 over m क्या आ जाएगा? It is basically, you can say it r. Okay. Now from here you get that x minus x naught mod less than r. इसका मतलब क्या है कि ये आपका इंटरवल ऑफ कन्वर्जेंस होगा. इंटरवल ऑफ कन्वर्जेंस कैसे फिर फाइंड करेंगे? यहां से हम इस तरह इंटरवल ऑफ कन्वर्जेंस फाइंड कर लेंगे. अगर आप यहां से इंटरवल ऑफ कन्वर्जेंस फाइंड कर सकते हैं, ऑब्वियसली यू कैन फाइंड द सेंटर ऑफ कन्वर्जेंस. सेंटर ऑफ interval of convergence is x naught and r is the radius of convergence of that interval. Okay, I hope you get it. Let's try these things again with the help of an example. If you have any confusion, you can ask me. This was the ratio test. Sorry, ratio test. There is another test which is called root test. Root test, I leave it as an exercise for you guys to see from the book of Thomas Calculus, chapter, sequence, and series. I think 9th chapter hai, या 10th chapter hai. Try to see those things. Root test क्या होता है? How do we check? How do we? उसका भी तकरीबन यही method है. सिर्फ आप देखेंगे तो I hope you will get it. How to use root test to check the convergence of the given series. वहां पे सिंपल सीरीज होंगी, पावर सीरीज नहीं होंगी. ठीक है, तो आप देख लीजिएगा. मे भी पावर सीरीज भी हो. देखिएगा कि रूट टेस्ट को हम कैसे चेक करते हैं. अब देखिए, लेट अस डिस्कस द कन्वर्जेंस ऑफ एनी गिवन सीरीज with the help of ratio test. Ratio test find the radius and interval of convergence of the series. Series कुछ भी हो, पावर सीरीज है तो ठीक है, नहीं तो फिर भी हमने रेशियो टेस्ट यूज करना है. So it is k from 1 to infinity minus 1 power k divided by 10 power k x minus 5 whole raised power k. So index of index क्या है? k है, यहाँ पे k है या n है, we don't mind. अगर k है तो हम सारी टर्म्स k में लिख लेंगे, अगर n है तो n में लिख लेंगे, because these indices are these are basically a kind of dummy index. अगर k की जगह कुछ और लिख दें तो it doesn't change anything in the power series. आप यहाँ पे n लिखें, p लिखें, s लिखें, आपने तो वेरी करनी है ना उसकी वैल्यूज और पुट करनी है यहाँ पे. You'll get the same thing even if you write some different index here. So this is your power series. We need to check where we need to find the radius and interval of convergence for this series. Okay. For what do we do here? In fact, we use ratio test. How do we use it? We write limit n तो नहीं होगा यहाँ पे k होगा. So k goes to infinity. दो consecutive terms लिखनी है इसमें. पहली ऊपर वाली k plus 1 के साथ लिख लेंगे हम. ठीक है. और साथ में x minus 5 whole power k plus 1. Ratio previous term. This is k with 10 raised power k and x minus 5 k. इसका आपने एब्सोल्यूट ले लेना है वैल्यू. अब इसको सिंप्लीफाई करना है. यहाँ पे 10 पावर k के साथ कैंसिल, और ये k इस k के साथ कैंसिल, ये k इसके साथ कैंसिल. तो हमारे what we are left with, limit k goes to infinity, mod of minus 1 power 1 times x minus 5 power 1, और नीचे क्या बचेगा 10. So this is what we have left with. We are left with. ठीक है, यही होगा. हाँ ठीक है. अब k पे लिमिट अप्लाई करनी है. k तो है ही कोई नहीं, या है यहाँ पे कहीं पे है k? नहीं है ना. So हमारे पास अब लिमिट अप्लाई करें इस पे. k है ही नहीं, लिमिट क्या होगी? लिमिट एब्सोल्यूट वैल्यू होगी. तो यहाँ पे मॉड ऑफ क्या आ जाएगा? mod of x minus 5 divided by 10. ठीक है. Now this is equal to what? This is equal to L, and L is it should be equal to less than 1. It should be less than 1. ठीक है. अगर ये less than 1 होगा तो 10 को उधर मल्टीप्लाई कर दें, x minus 5 mod less than 10. So this is your interval of convergence. Okay. Center of convergence is 5. Center of interval of convergence 5 and radius is 10. अब इसको सिंप्लीफाई करें हम तो क्या बनेगा? X minus 5 less than negative 10 less than 10. तो यहां से ये 5 उधर जाएगा, तो minus 5 less than x less than 5 उधर जाएगा 15. तो आपका इंटरवल जो होगा वो क्या होगा? negative 5 15. ये हो जाएगा. सो रियल लाइन पे क्या होगा? negative 5 से 15 तक. ठीक है. और इसका जो बेसिकली सेंटर होगा वो क्या होगा? 5. ये 5 होगा. ठीक है. और ये आपका इंटरवल ऑफ कन्वर्जेंस है, दिस वन. ठीक है. ये आपका सेंटर है, और आपका जो रेडियस है वो क्या है? 10 है. ठीक है. सो दिस इज योर r and this is your x naught. This is your x naught, which is the center of interval of convergence. So interval of convergence is this. Means, what does it mean? This is interval of convergence. What does it mean? Whatever the value of x you put here, from that interval, this series will be absolutely convergent. Okay. This will be convergent in short. I hope you get it. If you have any question, you can ask me. Next lecture में quiz होगा inshallah. Okay, there'll be no further delay in the quiz. If you have any question, you can ask me. So today we are going to stop here. Next time, we'll discuss how to solve differential equations. In fact, second order ODE with variable coefficient with the help of power series. If you don't have any question, okay, then good luck. See you next time, inshallah.